Hi everyone, this is a math guru. In this video, I'm going to show you how to solve the following Euclidean geometry revision question. We have, in the diagram, O is the center of the circle, ABCDE. The line AF is equal to the line FE. AG is a tangent to the circle at A, and the angle OAE is 40 degrees. So we have to fill in the box. We have the statement on the left, and the reason why that statement is true is written. So the first one says the line OA is equal to the line OE. Let's go back to the diagram. We have the line OA that's starting from the center of the circle, touching the circle, and then the line OE, the same. Note that when we have a circle with a center, any line drawn from the center of the circle to the side is the radius. So therefore, the line OA is equal to the line OE because they are both radii to the circle. So the reason will be they're both radii. The second statement says the angle EA is equal to 40 degrees. If I go back to the diagram, we already know that OA is equal to OE, that's the radii, and then we have the angle 40 degrees is equal to E1. Note that the triangle shown, that's OAE, that's an isosceles triangle, and we know that base angle of an isosceles triangle, they are equal. So the reason for that would be base angles of the isosceles triangle OAE. The next statement says the angle D is equal to 140 degrees. I'm going to make it clean. And then we have the angle at D. Note that if you look at the diagram given, we have the points C, D, E, and A touching the circumference of the circle. And what this means is ACDE is a cyclic chord. The opposite angles of a cyclic chord add up to 180 degrees. So we have one side equals to 40. So to make that up, the other side will be 140 because 140 plus 40 makes 180 degrees. So the reason will be we have opposite angles of a cyclic chord add up to 180 degrees. The next statement says the angle F1 is equal to 90 degrees. So I have that as 90 degrees. If you look at the diagram given, we've been told that the line AF is equal to the line FE. And we have a line coming from the center of the circle to the line AFE. The circle theorem states that if we have a line drawn from the center of the circle to a chord and which bisects the chord, then that line is perpendicular to the chord. So therefore, F1 is equal to 90 degrees because the line drawn from center bisects the chord. And if it bisects the chord, the line is perpendicular to the chord. The next statement says we have A1 equals 50 degrees. I have the A1, I'm going to highlight that. I have A1 equals 50 degrees. If you go back to the question, we've been told that AG is a tangent to the circle at A. So we have the line AG being a tangent. And we can see we have the radius OA, which is perpendicular to the tangent. So therefore, if you look at the total angle, that's OAG will be 90 degrees. and we already have the 40 degrees. So 90 minus 40 will make A1 50 degrees. So therefore the reason will be the tangent is perpendicular to the radius. That is, we have OA perpendicular to AG. The next statement says the angle B is equal to 50 degrees. I'm going to clean up what I have here. The angle B, that's the angle at the top here, is equal to 50 degrees. Please don't forget to click on the like and subscribe button below for more easy to understand math concept. From the previous statement, which says A1 is equal to 50 degrees, we can see that we have our A1 here, and we know that the line AG is a tangent to the circle. So therefore, note that the angle A1 is equal to 50 degrees, which is also equal to the angle at B, and the reason being that's the tan chord theorem, which states that if I have a circle as shown and I have my triangle, make sure that all the corners touches the circumference of the circle, and I have a tangent drawn, then therefore this external angle will be equal to the opposite interior angle of the triangle. That's the tan chord theorem. And the last but not the least, we have angle AOE. I'm going to highlight that. AOE is equal to 100 degrees. That's the theorem that states that. I'm going to draw that out. If I have this, if I have the circle as drawn with the center O, then the rule says that the circle theorem, the angle at the center is twice the angle at the circumference. So if that is x, this will be 2x. We know that we have B as 50, so therefore the angle at the center, that's AOE, will be 2 times 50 degrees, which is 100. So the circle theorem for that is angle at center equals 2 times angle at the circumference. Thanks for watching. Bye.